To begin with the second part of the unit, we will start with Ohm's law. Ohm's law is one of those fundamental rules which gives the relationship between voltage, current and resistance. It states that the voltage and current are proportional provided the resistance remains the same. V over I is a constant, and that is the resistance of the conductor. Now, Ohm's law, the equation can be easily remembered with the help of this triangle method. So if any two of those factors are given, the third one can be found out easily. That is, V is equal to I multiplied R, I is equal to V over R, or R is equal to V over I. The application of this Ohm's law we will see in our next topic, that is series networks and parallel networks. Now, coming to the most important part of the unit, electric circuits. So here you can see, or we can have an introduction about resistors. These are those basic components which are the essential part of any electric network, which controls the flow of current, or which can give rise to the desired value of current. Now, resistors can be connected in different pattern. As you see here, it's a complex network. So we'll start with the very basic connection of resistors, that is series connection, and then later parallel connection. So resistors in series. The series connection is the special connection where the resistors are connected end to end. The most important point here is that there is only one path for the current to flow. Network looks like this. So you need to focus here that the voltage provides the current, and the same current flows through the three resistors in this example, and the same current flows back to the power supply, completing the network. You can see here, this current flow gives rise to voltage drop across the element. We represent it here as V1, V2, V3. These are the voltages across the three different elements. The total resistance of a series circuit is calculated by the very simple rule, that is R total is equal to R1 plus R2 plus R3. Now, coming to resistors in parallel, the connection here is special so that there is a common point or junctions always found in parallel networks. So this is an example of parallel connection of three resistors. Now, the point here to be noted is that the total current, when it reaches the junction, this is one of the junction, it divides into branch currents depending on how many branches are there or how many resistors are there. You can find I1, I2, I3. These currents flow through these branches, and at the other junction they all combine together and give rise to the total current back again, completing the network. Now, the total resistance in this parallel network is calculated by a different rule. 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Now, there are so many advantages of parallel connection, that is, we can even use different powered elements in parallel connection, and they all have the same voltage. And the other advantage is, even if one of the component fails to operate, the other components still work, completing the network. We will have a look at the operation of series connection and parallel connection with the help of this video. Looking at a series circuit, an example will be those Christmas tree lamps. The problem with the series circuit is that there is a single current, or there is only a single branch or a single way for the current to flow. And if one of the element stops work, then the entire branch will stop working. We'll have a look at the series circuit. Here you can see different lamps are connected to the power supply in a series connection. There is only one way for the current to flow. If one of the lamp burns out or fails to operate, all the other bulbs fails. We'll have a look at a series circuit where there are many bulbs connected through a series connection. You can note here that there is only one way for the current to flow, and the result is that if one of the bulb fails to work, the other bulbs also don't receive the current and they are all off. Now let us see more details about the series circuit. They all have the same current, so let us see the total current at the two ends of the circuit. Just note it down here as 0.4 amperes. Now the current flowing through the first element, the current flowing through the second element, and the current flowing through the third element all are measured to be the same, which explains that there is only a single current flowing through a series circuit. Now coming to the information about the voltage, if you note down that the total voltage of the circuit is say 12 volt, and measure the voltage across bulb 1, measure the voltage across bulb 2, measure the voltage across bulb 3. If you add these three individual voltages, you will get 12, which is the total voltage supplied by the battery. That is, V is equal to V1 plus V2 plus V3. Now at this point, you need to note down one phenomenon of series circuit. This is called voltage division. That is, the total voltage by the supply gets divided into individual voltage drops, and when you add the individual voltage drops, you will get back the original source voltage. Now, coming to the information about the total resistance, as you saw before, the total resistance of a series circuit can be easily calculated by the rule R is equal to R1 plus R2 plus R3. Now, looking at the same features of parallel circuits, a parallel circuit provides individual path for the current to flow, and that's why most of the appliances in our home are connected through parallel connection. As you can see here, there are individual path or individual branch for the current to flow. Even if one of the device fails to operate, the other devices can still work. That's the advantage of parallel network. You can see here the TV fails to operate, but the lamp still works. Okay, now more specific about the current, voltage, resistance information. As you can see here, the total current coming to the details of voltage, current and resistance of a parallel circuit. The total current in a parallel circuit is equal to the sum of the currents in the individual branches. If you notice here, the total current is measured near to the battery and it's found to be 4.32 amperes. Now, if you measure the current of the first branch, note down 2 ampere, second branch is 1.6 ampere, third branch is 0.72 ampere, and if you sum them, you get the current as 4.32 ampere, which is the total current you measured before. So it is the current which gets divided here. So current division is an important operation inside parallel circuit. Now, the information regarding the voltage, they share the same voltage. You measure the voltage across any element in a parallel circuit, you will find that the voltage is the same. The voltmeter reading across the first element, the voltmeter reading across the second element, the voltmeter reading across the third element, all are the same as the supply voltage. The total resistance of a parallel network is calculated by the rule 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. One thing here that you can notice is the total resistance of a parallel circuit decreases as more branches are added to the circuit. So let's have a comparison between a series network and a parallel network. So here we have 3 elements connected in series. So as you see here, the current remains the same, but the voltages are different. And these voltages are... So let's have a comparison between series network and parallel network. Okay, starting with the series network. So the information about the current is that there is only a single current flowing through the entire part of the circuit, but the voltages can be different. And these voltages are derived from the supply voltage, or we say that the supply voltage gets divided into individual or separate voltage drops. So in a series network, voltage divides. How do you calculate this voltage divided? Is by a voltage division rule, which is represented by the equation Vn is equal to V total over R total multiplied with Rn. For example, if you want to calculate V1, then the equation will be V1 is equal to Vt over Rt multiplied with R1. If you want to calculate V2, the equation will be Vt over Rt multiplied with R2 and so on. Vt over Rt remains the same, which is in fact the total current flowing through the network, and whichever voltage you want to find out, you just need to multiply that particular resistance in the equation. It's very simple. Coming to the parallel network, as you can see here, the voltage remains the same, but it is the current which gets divided. So it is the current division. Now the current division is applied in a slightly different way, or the rule is slightly different. Okay, now coming to the parallel network, as you can see here, the voltage remains the same for the different branches, but the current gets divided. So it is the current division that happens to a parallel network. Now the current division is applied or used in a slightly different way. I mean, the equation is slightly different. Okay, let's see here the equation. I1 is equal to I total divided by R1 plus R2 multiplied with R2. That is, if I want to find out the current flowing through the first branch, in my equation I'll be using the second branch resistance. It over R1 plus R2 remains the same for all the branch calculation, but only this resistance value changes. And you need to be very careful here, and the students often make mistakes in taking this second branch resistance. Once again, if you want I1, it's multiplied with R2. If you want to calculate I2, you will multiply with R1. I hope you note down these major differences. In voltage division, we take the same resistance, but in current division, we have to take the opposite branch resistance. In other way, voltage division can be applied to as many resistors that are connected in series, but the current division we normally apply to only a network of 2 resistors connected in parallel. If you have more resistors connected in parallel, then you need to make a small modification or a rearrangement to the network so that finally it looks like only two resistors.